For this video, we're going to be discussing the transcendental functions and indeterminate forms. When we say transcendental functions, it includes the exponential functions, logarithmic functions, trigonometric functions, and the inverse functions of them. Let's have examples. For letter A, we have exponential functions. 1. F of x is equal to 6 raised to the quantity of the difference of 2x and 5. Number 2. F of x is equal to 1/2 raised to the quantity of the sum of 5x and 2. Let's have examples of logarithmic functions. For number 1, f of x is equal to the logarithm of the quantity x squared plus 2x plus 5 with a base 5. Number 2, f of x is equal to logarithm of 3x minus 5 all over 5x minus 7x squared. This is basically with a base of 10. For letter C, we have the trigonometric functions. Number 1 example is f of x is equal to sine of the quantity 2x squared plus 5x plus 6. Number 2, f of x is equal to the cosine of the quantity 4x minus 16. So these are the examples of transcendental functions. Let's move on to the indeterminate forms. When we say indeterminate form, it is an expression involving two functions whose limit cannot be determined solely from the limits of the individual function. This is if the limit of the function f of x as x approaches a is equal to the limit of g of x as x approaches a, and these two are equal to 0. Then the limit of the function f of x over the limit of the function g of x as x approaches a might equal to any number or even fail to exist. Let's have an example. Evaluate the limit of x minus 2 all over x squared minus 4 as x approaches 2. And by direct substitution, we can easily determine that this function does not exist or indeterminate. So let's see. By direct substitution, we have this. We're going to have 2 minus 2 in the numerator and 2 squared minus 4 in the denominator. Then it will yield 0 over 0, which is indeterminate. And here we're going to think for a possible way on how to find the limit of our problem. And this is by factoring the denominator. So in the denominator, we're going to have the factors of x minus 2 and x plus 2. These are the factors of x squared minus 4. Then we can cancel x minus 2 in the numerator and x minus 2 in the denominator. Then yung matitira dito will be 1 over x plus 2. And by substitution, we're going to have 1 over 2 plus 2, and the limit exists at 1 over 4. Let's have the first problem in our transcendental function. Complete the table of values representing the two one-sided limits of the given exponential, logarithmic, and trigonometric function. Evaluate the limit of a function by observing the table of values. Number 1. The limit of 2 raised to the quantity of the sum of x and 2 as x approaches 1. The first thing that we need to do here is to set values for x. So let's have the table of values. So in the first row, we have the x. And second row, we have the f of x. At dito, tayo yung magsaset ng values dito na ipapakita natin na ang values ng x ay approaching 1. So yung one-sided limits, makikita natin here, the limit of 2 raised to the quantity of x plus 2 as x approaches 1 from the left of our 1. That's why we have negative here. It indicates that the values here are less than 1. Then, the other one-sided limit is here. The limit of 2 raised to the quantity of the sum of x and 2 as x approaches 1 from the right side of our 1 or greater than 1. Then from here, let's obtain the values of our function one by one. So you can use your calculator in obtaining the values of each value of x. So if x is 0, the function is 4. If x is 0.5, the function is 5.656854. Then, here. And from the right side, let's start with 2. The value is 16. If 1.5, this is the value. If 1.01, this is the value of our function. If 1.0001, the value of the function is this. And as you can see, from left and from right side, they are approaching specific number, and that is 8. And from the table of values, we can evaluate the one-sided limits. So by evaluating the limits from both sides, we have the limit of 2 raised to x plus 2 as x approaches 1 from the left is equal to 8. Then, the limit of 2 raised to x plus 2 as x approaches 1 from the right is also equal to 8. Since the two one-sided limits are equal, our limit exists at 8. Ngayon ay tingnan naman natin yung graph ng ating function. F of x is equal to 2 raised to x plus 2. Makikita natin dito sa dot na to, this is the limit of our function. At yung nasa left side niya, that is the limit of 2 raised to x plus 2 as x approaches 1 from the left. Then, the other side, that's the limit of 2 raised to x plus 2 as x approaches 1 from the right. And through this, we need to consider the formulae below. The limit of a raised to x as x approaches positive infinity is equal to positive infinity. And the limit of a raised to x as x approaches negative infinity is equal to 0, where a is greater than 1. Let's solve our problem number 2. So this is an example of logarithmic function. Evaluate the limit of the logarithm of the quantity 3x plus 1 with a base 10 as x approaches 3. So first thing is we need to set values for x. Here we have 2, 2.5, 2.99, 2.999, and 3. So this part, ito yung from the left natin. Then 4, 3.5, 3.01, 3.0001. Ito naman yung from the right. Now let's obtain the values of our function by substituting the values of x and by using your calculator. So if x is 2, the value of our function is this. If 2.5, this is the value. If 2.99, here. For 2.9999, here. If x is 4, this is the value. If x is 3.5, here. If x is 3.01, if x is 3.0001, and as you can see, both sides, they are approaching to a specific number, and that is 1. And from here, we can evaluate the two one-sided limits. So by evaluating the limits from both sides, the limit of the logarithm of 3x plus 1 as x approaches 3 from the left is 1. And the limit of the logarithm of 3x plus 1 as x approaches 3 from the right is equal to 1. Therefore, our limit exists at 1. And by looking the graph of our function, here it is. F of x is equal to logarithm of 3x plus 1. So this is basically with a base of 10. This part is from the left. That is the limit of the logarithm of 3x plus 1 as x approaches 3 from the left side. And from the right side, here it is. So they are approaching to specific number, which is 1. So as x approaches 3 from left and from right side, the value of our function is approaching 1. Let's answer the third problem. Evaluate the limit of 4 sine of 2x as x approaches 3 pi over 4. So here let's set the values for x. As you can see here is 3 pi over 4, and in unit circle, this is equivalent to 135 degrees. Then kuhanin natin yung mga radian measures na katabi niya sa unit circle. We have the 2 pi over 3 which is 120 degrees and 5 pi over 6 which is 150 degrees. Then kuhanin lang natin yung mga radian measures in between them. So if we're going to add 2/3 and 3/4, kung ano yung magiging sum niya, i-divide lang natin sa 2. And that will be 17 over 24. Then 17 over 24 plus 2/3, kung ano yung magiging sum niya, i-divide lang natin sa 2, and that is 11 over 16. And 17 over 24 plus 3/4, kung ano yung magiging sum niya, i-divide lang natin sa 2, and that is 35 over 48. At ganun din sa ating right side. Ito yung values ng x natin from the left of 3 pi over 4. At ito naman yung mga values ng x natin sa kanan. Now, let's obtain the values of our function by substituting the values of our x. But before that, make sure that your calculator is in radian mode before you plug in the values of x. For 2 pi over 3, the value of our function is this, negative 3.464101. If x is 11 pi over 16, here's the value. In 17 pi over 24, in 35 pi over 48, and here in 5 pi over 6, in 11 pi over 6, in 19 pi over 24, in 37 pi over 48, here is the value. And as you notice, they are approaching same number, and that is negative 4. Now, by evaluating the limits, we have the limit of 4 sine of 2x as x approaches 3 pi over 4 from the left is negative 4. And the limit of 4 sine 2x as x approaches 3 pi over 4 from the right is also negative 4. So our limit exists at negative 4. So kung titingnan natin siya sa graph, here is the graph of our trigonometric function, 4 sine 2x. And here is our 3 pi over 4. From the left side, here it is. The limit of 4 sine 2x as x approaches 3 pi over 4 from the left. And from the right, here, the limit of 4 sine 2x as x approaches 3 pi over 4 from the right. Now, let's have more examples of transcendental functions. Number 1, the limit of 1 over 3 raised to 2x minus 5 plus 3 as x approaches 3. So from here, we can do the direct substitution. And by doing so, we have 1 over 3 raised to 2 times 3 minus 5 plus 3. Then just simplify, we're going to have 1 over 3 raised to 6 minus 5 plus 3. Then we have 1/3 plus 3, and this is equivalent to 10/3 or 10 over 3. Number 2, we have the limit of e raised to 2x minus 3 plus 7 as x approaches 5. Let's have a short introduction regarding e. E is called the Euler's number. Just like our pi, it has a constant value. So kung yung pi natin is 3.1415925 and so on, our Euler's number is 2.71828182845945 and so on. When e is used as the base for a logarithm, we call that logarithm the natural logarithm and write it as ln x, or the natural logarithm of x. And let's go back to our example. So by substitution, we're going to have e raised to 2 times 5 minus 3 plus 7. Then by simplifying the exponent, we're going to have e raised to 7 plus 7. And you can use your calculator to find the exact value of this. We're going to have 1103.63. Third example, we have the limit of the logarithm of the quantity 2x minus 4 with the base 2 plus the logarithm of the quantity 7x plus 4 to the base 2 as x approaches 4. So also here we can use the direct substitution. We're going to have the logarithm of the quantity 2 times 4 minus 4 with base 2 plus the logarithm of the quantity of 7 times 4 plus 4 with base 2. And from here, we can simplify the expressions inside the parentheses. And that will be, in the first term, we have the logarithm of 4 with base 2 plus logarithm of 32 with base 2. And from here, we can have 2 plus 5 because logarithm of 4 with base 2 is equal to 2 and logarithm of 32 with base 2 is equal to 5. So, paano natin nakuha yung values nila na ganun? By simply transforming each term in exponential form. So, let's have the first one. We have x is equal to logarithm of 4 with base 2. So, by getting the exponential form, we're going to have 2 raised to x is equal to 4. Then, just solve for x. We're going to have 2 raised to x is equal to 2 raised to 2, which is x is equal to 2. That's why we have 2 in our first term. For our second term, we have x is equal to logarithm of 32 with base 2. Then by transforming it into exponential form, we have 2 raised to x is equal to 32. Then just find the value of x. So we have x is equal to 5. That's why we have 5 here. So the limit of our problem number 3 is 7. For our number 4, we have the limit of 2 raised to sine of x over 6 as x approaches pi. In this example, we can say that our theta is in radian measure. So by direct substitution, we're going to have 2 raised to sine of pi over 6. And by using our unit circle, sine pi over 6 is equal to 1/2. Then 2 raised to 1/2 is equivalent to square root of 2. And that is the limit in our number 4 problem. Now let's answer number 5. This is an example of indeterminate form because if we're going to do the direct substitution, in the denominator, we're going to have 0. So we're going to think for another way on how we're going to find the limit of this problem. And that is by factoring. So we're going to factor the numerator. And the factors are x minus 6 and x plus 4. Then we can cancel x minus 6 in the numerator and x minus 6 in the denominator. And the remaining part is x plus 4. Then let's evaluate the limit from this step. So we have x plus 4 is equal to 6 plus 4. And the limit exists at 10. For our last example, we're going to have the limit of the square root of the quantity x squared plus 3 minus 2 all over x squared minus 1 as x approaches negative 1. Obviously, we cannot do the direct substitution here because if we do, we have negative 1 squared, that is 1. So we have 1 minus 1 in the denominator and that is 0. And we cannot do the factoring here. Another way in finding the limit of this problem is by multiplying the numerator and the denominator by the conjugate. And the conjugate is the square root of the quantity x squared plus 3 plus 2. Here. From this step, what we need to do is to apply the sums and difference in multiplying the expressions in the numerator. So first term to first term, second term to second term. And that is x squared plus 3 if we're going to multiply the first term to first term, and negative 4 last term to last term. Then simplify the numerator, we have x squared minus 1. And as you can see, we can cancel x squared minus 1 in the numerator and x squared minus 1 in the denominator. So the remaining part is 1 in the numerator, and in the denominator, we have the square root of x squared plus 3 minus 2. So by direct substitution, we have 1 all over the square root of the quantity negative 1 squared plus 3 plus 2. Then just simplify, we have 1 all over square root of 4 plus 2, and square root of 4 is equal to 2 plus 2, that is 4. So our limit exists at 1/4. And this is the end of this video. If you find this video informative, please don't forget to like, share, and subscribe. Thank you for watching. God bless us all.